ATP synthase is a very essential enzyme complex to our metabolism. Found in the mitochondria, it is directly responsible for catalyzing the formation of ATP from ADP and inorganic phosphate. ATP synthase is composed of two main subunits, F1 and FO. FO is a subunit which is bound in the mitochondrial membrane, and it is basically a pore in the membrane which allows protons to travel from one side to the other. F1 is the subunit protruding from the membrane into the mitochondrial matrix, and it is the subunit responsible for forming ATP. Specifically, it binds ADP and inorganic phosphate and puts them into a favorable position for forming the product ATP. ATP synthase works by utilizing the power of potential energy built up from a proton gradient. As protons flow from the intermembrane space down their gradient through FO into the matrix, FO rotates. FO rotating causes F1 to rotate and go through a series of conformational changes which form ATP. In this way, ATP synthase is very similar to a turbine or windmill which generates energy as they rotate. Also note that for every 3 to 4 protons that travel through ATP synthase, one molecule of ATP is formed. As mentioned before, ATP synthase utilizes the proton gradient in order to power formation of ATP. Therefore, maintaining the gradient is essential for ATP synthase to function. As a reminder, a gradient is formed when one side of a membrane has a higher concentration of ions or specific molecules than the other side. Molecules naturally want to move from high to low concentration, so there is a lot of potential energy found in gradients. As mentioned several times already, ATP synthase relies on a gradient of protons for its power source. As the protons continue to travel down their gradient, however, the concentration of protons on both sides begins to equalize. To maintain the gradient, protons are pumped into the intermembrane space by a series of enzymes bound in the same membrane as ATP synthase. This series of enzymes is known as the electron transport chain, or ETC for short. What powers these enzymes is a series of redox reactions involving oxygen and the cofactors NADH and FADH. We won't go into detail about how these reactions work, but just know that the protons are pumped into the intermembrane space as electrons taken from NADH and FADH are given to oxygen.